All right, so good morning, everyone. Thank you for having me today. I'm really excited about presenting about how Loop built a $100 million plus company using Google Cloud. And thank you to Glorium for putting together this event. It's really amazing to see such an event being put out for free. The presentation is going to focus how Loop leveraged Google Cloud Platform in order to build not only for our current needs as a startup, but also to account for scale and growth in the future, so that you see some of the challenges we faced, and then you can apply them hopefully to your problems as well. In order to make this presentation as valuable as possible, I thought it would be amazing to start with setting up some of the objectives and some of the key results that we want to go through today. So first, we want to understand what goes into scaling your infrastructure and team to account for business growth. And the way we're going to target that is by looking at first the Loop's mission and current scale. That's really just to set a target for us to build towards. Second, we're going to look at some of the key needs and pain points that all of growing startups are going to face. Now, you might be currently building startups, or you might be in already established businesses. Either or, I think everybody can get value out of looking at some of those challenges and seeing how we solved for them. And then maybe in the Q&A, you can give us some of the solutions you've found for those issues. And finally, and very importantly, we're going to identify GCP offerings that help solve those pain points. So Google Cloud Platform has a suite of products that can touch pretty much any pain point. Well, not any pain points, but solve for a lot of issues that companies that want to build on the cloud have. And we're going to identify a small subset of those today based on a specific use case that I'm going to be putting forth. So first, let's start talking about Loop as a company. This is, remember, this is just to give us a way to set a target that we're building towards. So Loop is a mission-driven and AI-powered car insurance company, creating fair insurance for all. Sorry, let me just get rid of that one. Yeah, so what that really means is Loop's main focus is on making insurance accessible and fair. There are a lot of pricing factors that go into insurance, and we believe that not all of them have their place in pricing you as a risk. So we're getting rid of some of those, such as financial stability indicators in education, and we're replacing them with measures of risk of the road and measure of risks of how you drive. And I'll go into that a little bit more in the next slides. So how do we do that? How do we go and replace, or how do we get rid of financial stability indicators when it comes to car insurance? Well, by looking at the road segments outside of your neighborhood, your city, where you live, where you're most likely to drive, and by quantifying the risk on those roads. The way we do that is by looking at a few different variables. We look at the history of crashes. So we can look over the last 10 years of crashes that happened within a certain state and actually pinpoint those on the road. We look at the weather conditions that happened during those crashes. So at the time those crashes happened. We look at the roadway infrastructure. There is B roads, A roads, there is 2-lane roads, there is 3-lane roads, there is highways, there is back roads. So many differences in the road can affect whether or not that road is more likely to have a crash, such as right turns, right only, left turns, off ramps, on ramps. Those are all very important in determining the riskiness of a road. And we look at traffic volume, right? Traffic volume is a huge determinant because a very crowded road or a very empty road can have very different driving behaviors on it from one to the other. So how do we work as an insurance company is by looking at the roads right around you, we're able to see which roads are you most likely to drive on based on the traffic patterns of people that live in that area. And then we offer you an insurance price that is based on that. Once you're with us, we measure how you drive and where you drive. So we look at behaviors, so harsh acceleration, speeding, excessive speeding, and things like that. And we kind of like build a profile of, is this a person that is usually speeding, or is this a person that is usually safe? Is this a commuter, a 9-to-5er, or something like that? Then we try to engage with you. So we look at some of the things you're doing on the roads and how they can negatively or positively impact your rate. And then we try to engage with you to coach you on how to drive. And finally, we refine your rate at renewal. So when it comes to the time of 4 months after your policy we have 6 months policies, insurance policies. 4 months after the initiation of your policy, we look at your renewal rate, and then we can offer you, if you follow our kind of like tips and tricks on how to drive, you're most likely going to get a reduction in your insurance price come the next period. So just some numbers. These kind of slides are very hard to keep up with because they move so fast when you're in a startup. So we were indeed funded in 2022. We raised a seed round of 3.2 million, followed by a Series A of 21 million. We've partnered with the third largest reinsurance company in the world, and they offered us $30 million of reinsurance capacity. Employee count actually 50, that actually is now closer like 65. And for our customer wait list, the reason we still have a customer wait list is because we are operating only in the state of Texas, and we have other states where people are joining our wait list waiting for us to go to those states. What you have to know is insurance is regulated at the state level. So you don't just build an insurance program and go sell it everywhere. You build it and you get it approved in one state and you sell it there, and then you get the approvals for the subsequent states as well. And we're currently operating in the state of Texas, as I mentioned. We're selling insurance in the state of Texas. So in order to build to what are these tools that you can use to face some of these issues, we just kind of like, I just wanted to put forth a fictional startup. We're going to look at a fictional startup that I called Soup. Looks like, sounds like Loop, and I can't really speak about Loop specifically. So Soup is a B2C startup that needs to reach its customers on multiple platforms. Think of it as mobile, web, and any other platform really. And integrate with many third-party and SaaS applications. Soup has limited resources, so some of the key important things for Soup are going to be speed to market, capital efficiency, which are going to be a huge role. Which are going to play a huge role in actually the tools we select and how we use them. So we're going to go in 3 layers here. We're going to talk about some of the developer tools that every startup needs, some of the compute infrastructure, and I snuck in quite a bit of managed services in that one just because I think they're very, very valuable for startups. And we're going to look at storage. Every company that serves customers needs to store some sort of data at some point or another, and we have a few different ways to store data in GCP that I'm going to be talking about. At the bottom, I said here, GCP also offers a suite of tools for networking, data science. Loop uses a lot of those. For the sake of the presentation, I'm not going to go too into detail into some of those. So first, let's start with developer needs. So Soup needs a few tools for their developers and cloud engineers. At the bare minimum, they need a code repository. They need a deployment tool to automate the CI/CD pipeline. That one is really important. If you have your developers working in local environments only without the ability to push to the cloud, you are going to have so much of a difference between your cloud environment and your local environment. And when you're going to try to make your push, after a month of development or something, you're going to face a lot of issues. So having a pipeline that allows you to deploy code as often and as early as possible is really, really powerful. And then a centralized platform to sync all logs, metrics, and traces. And I'll talk about why that's very important. So first, for the code repo. GCP offers its own remote repo called Cloud Source Repositories. You're going to see throughout the presentation, they're very straightforward with their naming of their products. That allows you to create a code repository within your cloud environment, access commit details, so you're able to maintain your Git workflows, access commit details to view line changes and file differences. You can set up local authentication. This is really how you allow your team to be able to contribute to the code, is by setting up local authentication for them. You're able to automate deployments to serverless compute resources, such as App Engine, Cloud Functions, and Cloud Run. We're going to discuss some of those later as well. And very importantly, if you want to use, or if you want to take advantage of the automated deployments to App Engine and Cloud Functions, but you don't want to migrate off of GitHub or Bitbucket if you're already working on them, Google Cloud Source Repositories allows you to mirror those buckets, mirror those repositories. So instead of migrating, you can just set up a mirror, and whenever you can keep working on Bitbucket or GitHub, your changes will be reflected also in Cloud Source Repositories. These are just some screenshots that I grabbed online that show you sorry, get in here that maybe I'm frozen. So yep, I'm just going to continue, I guess. So this is just to show you that like some of your familiar platforms like Bitbucket or GitHub are going to show you things very similar to this. So Google Cloud repos, there's not really source repositories, there's not really, kind of like move quite away from the natural workflow that engineers and developers are really used to. Next, we're talking about CI/CD. So Cloud Build is a serverless CI/CD platform that allows you to build deployment pipelines and connect them to your source code repositories. So there's quite a bit of amazing features that come with CI/CD. First, native Docker support. So you don't have to learn a new language. You don't have to do anything new. If you're containerizing your applications already using Docker, if you just have a Docker file or a Docker compose within your root repo, in the root of your repos, you can directly plug that into Google Cloud Build, and it will be able to containerize your application, run whatever tests you need to run, and push it forward. The ability to integrate with Google Container Registry or Artifact Registry. So we use Google Container Registry. I believe Artifact Registry is the new version. So they're continuing support for container, but they're kind of like trying to make everybody move to Artifact Registry. That's basically where you keep all of your containers and your images. It has a very generous free tier. So for small startups, that's really important. So you don't have to worry about paying for your deployments. So that's 120 minutes of build time per. Totally forgot per what. I think it's per month and up to 10 concurrent builds. It has integrated vulnerability scans. This is also very important for startups because you don't have really the capacity to keep up with every vulnerability that is on the images you will be using on your containers. So you can have an automatic vulnerability scan by Google as soon as the images land on the container registry. Insights for ease of debugging if a build fails, and I'll show you a screenshot of that here in a second. You're able to monitor your builds and actually see if they fail or if they succeed. And then you can integrate notifications, which is really important. We have it hooked up to Slack, for example. Whenever somebody makes a build, we just get notifications in a DevOps channel. That way we can keep appraised of everything that's happening. Oh, and of course you can connect this to Bitbucket, GitHub, or cloud source repositories. This is just a screenshot that shows you a history of builds. This is not from our builds. This is something I took online. We have the same exact platform and view. These are all the builds, and you can see some of these have failed, some of these have succeeded. And you have from here the ability to not only look at the source, look at the exact commit actually, so that you can see what happened in the code, but also look at the logs of the build so that you see step by step in your pipeline what went wrong if you did in fact have a failed build. Next, let's move to monitoring. Having visibility into your deployed applications is vital, especially when it comes to distributed resources such as microservice architectures. It's really important to have a place to put all of that together. Observability offers the ability to funnel all metrics and logs to a centralized location. One thing that is very important for startups specifically, most products in GCP that we'll be discussing today come with out-of-the-box reports for infrastructure and network metrics. That's a vital element. That means you don't have to have the expertise to build them. You can just use them and then start to learn how you can improve them. So some notes here. You can query specific resources, specific projects and resources for their logs and metrics. You don't just have like a huge dump. You can actually use a query language to go for a specific time frame, a specific resource, and a specific interaction. You can define uptime checks to make sure that your services, your critical workloads are always up and running. And you can define also SLOs, latency and availability. This is just a screenshot from one of the out-of-the-box like observability features that you get from Cloud Run. As you see, out of the box, without any integration, without any additional development, you get request counts, you get latencies, container instance count, because if you have auto scaling, you want to keep a close eye on that. Billable container instance time, CPU utilization, and container memory utilization. All of these come out of the box. I didn't have to do anything to get this kind of insight on my deployed applications. Finally, we have tracing. So while logs tell you what happened inside of your component, traces are used to show the interaction. So usually something that is end-to-end. Once a user triggers your API gateway, all the way to your microservices, a database read and back. Tracing allows you to see that a whole workflow and be able to determine what is taking the most time, where is your application lagging, what has the most latency, and things like that. Very importantly, also it comes with out-of-the-box functionality for anything running on Cloud Run, Cloud Functions, and App Engine Standard. So if you deploy your applications on one of these platforms, you will have tracing out of the box without having to really go and manually install your agents on your code. Of course, you can always enhance it, but it comes out of the box. And this is what tracing really looks like. You have all of these are individual requests. And then if you click on one of these requests, you get the breakdown of what happened from end to end. And you can also get to, it's not shown here, but you can get to the logs for that specific point in time, for that specific resource from this command line. When it comes to compute infrastructure, Soup needs compute infrastructure and some managed services to deploy their applications and make them available. So they need a backend services and customer-facing application, which is containerized. They need event-driven functions, an API gateway, of course, to connect all of their microservices, some load balancing to expose that to the world, and WAF and DDoS protection, because if you have a load balancer, you want to make sure that it's adequately protected. So assumption here is Soup's application is containerized. We all know the benefits of containerization. I'm not going to go too much into it. It's efficient, it's consistent. Avoid lock-in because it's portable. You can deploy it wherever you want, and it offers faster startup. So for GCP offers many compute resources such as VMs and App Engine. However, for Soup's purposes, for running containerized applications, there is Google Kubernetes Engine and Google Cloud Run. We went for Cloud Run because it's fully managed and we don't have to really do container orchestration or kind of like traffic management. So every Cloud Run service comes with a generous free tier, which is 2 million requests per month, automatic scaling down to 0. That's very important because if it's 0, if it's at 0, you're not being charged for it. It gives you a unique URL that you can then link to a gateway for every instance. Well, not for every instance, but for every service. And then it gives you automatic traffic management. That means if you deploy a new version of your service and you want to just give it 2%, let's say, of traffic, you can do that by keeping the old version already running until you're sure that your new version doesn't have any problems. And it comes integrated with security. So you can control who can access it, internal traffic only, internal and external traffic. You can require authentication by the use of service accounts. Moving on to event-driven. For small event-driven or scheduled tasks, Cloud Functions is really amazing. It allows you to deploy code without worrying about container management, handle scaling up and down to 0, up to Google scale, of course, dedicated URLs to call the functions, and then you can schedule these functions using Cloud Scheduler. Cloud Scheduler is another platform, is another product. Think of it as basically a cron job. It just allows you to call, like to trigger an event at a certain time interval. Alternatively, if Soup needs more computing power for their scheduled or event-driven jobs, they could use also Google Cloud Run jobs. Managed services. In addition to deploying their application on the cloud, Soup needs to make them accessible to their clients. For that, they will need a few things. So if you keep in mind, we have our Cloud Run services running now. We have our developers being able to code and push updates to those. Now we need to connect those all together. Well, they need an API gateway for that. So Google, of course, named it API Gateway. It is a fully managed and built for serverless workloads API gateway. It has built-in authentication, and it comes with out-of-the-box monitoring. Fully managed meaning you don't care about scaling, resource provisioning, or anything. Built-in authentication within your YAML file to define the API gateway, like the inputs, the required inputs, the URLs that they're hidden at the back. You can define if any route needs to be authenticated. You can choose between token authentication, something like Auth2 or OpenID Connect, and you can just use static API keys if you want to, if you wish to. On top of that, this API gateway can be linked to a load balancer for HTTPS load balancing, which is available through Google Cloud Load Balancing, which is a fully managed service with integrated failover strategies and multi-region availability. Now, that's really important because if you have a problem in one of your regions, you want the load balancer to be able to quickly divert that traffic to an instance that is running and continue your workloads without you having any type of downtime. And finally, it is also integrated with Cloud Armor, which allows you to, just by enabling it, protect yourselves against DDoS attacks without you having to do anything, and set up some WAF rules. Some of the WAF rules that can be, just an idea for WAF rules that can be interesting. For example, in our lower environments, we want to kind of like fake that we are exposing our endpoints and our load balancer to the world, but we don't want anybody to be able to access them because we're still developing. For that, we use Cloud Armor to block all IPs besides like the ones that we know are coming from our developers. That's one use case for it. I'm sure there are many others. For storage infrastructure, Soup needs the ability to store transactional data in a relational database. That's for business data. A data lake as a landing place for all their third-party sources. We usually call those D1 data sets. And then a data warehouse to perform analytics at scale. Those are D2As, which are D1s that are clean, and D2Bs, which are a set of different variables from different data sets that are geared towards a specific use case. So for transactional data, Soup can use Google Cloud SQL. It's a fully managed database service where you can bring in your MySQL, Postgres, or SQL Server databases. You don't have to change technologies. They basically just give you the infrastructure to run your existing technologies. They also have a service, I forgot the name of it, but there is an appliance in GCP that allows you to migrate your current MySQL, Postgres, or SQL Server databases to Google Cloud SQL without having to manage migration-specific resources and workloads. It also allows you to have automated provisioning for resources, integrated analytics, so you can track which queries are performing, which queries are not. Editing integrates with all of the compute infrastructure that discussed before. So you don't have to build anything to manage who can access your database or no. You can just say this Cloud Run service with this service account can access my database, these others cannot, and that allows you to just protect your database from the get-go. When it comes to the data lake, there are multiple approaches. A lot of people like to put it in the same place as their data warehouse. So people using Snowflake, for example, can do that. People using Google BigQuery as well can do that. But I think of Google Cloud Storage is just kind of like a place to dump all of your data that is coming from any source you have. And it's a perfect use case for a data lake, right? Google Cloud Storage allows you to have different configurations to fit your needs. So data that you will need to access every day versus data that you will be accessing once a month, for example, or less than that, up until data that you don't need to access for a whole year, like archive data or just kind of like compliance archive data. You have some data says that you need to store for a certain amount of time for compliance reasons. Well, GCP will not charge you a premium for those. It will charge you a lower rate because they can be stored in a place where there are a little bit like more latency to reach them, because the expectation is that you will not be reading those data sets every so often. You can have regional redundancy and also zonal redundancy, I believe, with the Google Cloud Platform, cloud storage that allows you to have fail-safe strategies. You can interact with your data directly for the command line, so your developers don't have to go to one place to see the data and then to their IDEs. If they have gcloud or GSUtil, they can directly write an LS and see all of the data and how it's stored. And it's highly configurable access permissions at the bucket or object level, which is then again going into that security piece. Sorry. For storage infrastructure, for the data warehouse, BigQuery is what we use. It's fully managed and serverless, so we only pay for when you use it. It's highly scalable, and very importantly, most startups don't have like a Tableau license or a Looker license, or they can use Google Data Studio, which is free, and it integrates with Google BigQuery so that you can use the BI engine from BigQuery to make your dashboards very performant. And now, finally, how to organize these resources. The organization starts from, first there is the org, which is the company. Then you have folders within that organization. And finally, you have projects that have associated single resources. Now, the reason it's displayed like this in a hierarchical manner, because identity and access management really happens top down. So if I'm an owner at the company level, I will have access to all of the resources below it, and I will have pretty much ownership access over them. Now, for example, somebody who has access to product 2 here will not have access to any of these things that are in product one, will not have any of these things that are in team A, department Y, and all of those above. So it's really important to understand how to structure this, because it will kind of like give you a identity and access management top down. And finally, this is just something I put together for Soup, the fictional startup. I would probably have a centralized cloud. I would have the organization at the top. I would have a shared VPC project that basically controls my networking, a centralized monitoring project to sync everything into for visibility, a centralized cloud build project for all of my CI/CD pipelines, a data layer that I can control permissions very granularly in, and then I can have as many of the environments as I want for Cloud Run and the load balancer and the API gateway. Here I put development and QA. We can have dev, QA, UAT, pre-prod, prod. Although for prod, I would actually have a whole other folder on the side, just so that there is no kind of like access permission confusion when it comes to production. And that's pretty much it. Some of the final thoughts, some of the closing thoughts that I had for today was, these are very, what I shared today is like a subset of what GCP offers in terms of resources and products. I tried to build it based on that specific Soup fictional startup by identifying some of the needs that every startup will face at some point or another. There are a lot more when it comes to AI, machine learning, and other specific use cases. But I hope this was helpful for everyone. And finally, if you have any questions, this is my email, this is my LinkedIn. Luke is hiring. Please feel free to reach out to me on LinkedIn directly. Hey, JV, I can't hear you.
Sorry, I was on mute. I apologize for that. Can you hear me now?
Yep, I can hear you.
Awesome. That was awesome. Thank you so much for sharing that with us. That's a great presentation. I'm really I live in Texas, actually, so I'm in Dallas. I'm looking forward to checking Loop out. I was unfamiliar that y'all were only in Texas, so very cool. I guess, do we have any questions for Ali, and any final thoughts on your end, and maybe where people can connect with you?
For final thoughts, I will say GCP. I'm a big fan of GCP, of course, as you know. I'm a certified fellow with them. I really love their products. Loop was able to build on GCP in such a way that allowed us to not have too much time before being able to see results. That was one of the most important things, is that like GCP allows you to get up and running very quickly. And for that, I believe it's a platform that will continue to grow and perhaps even overtake Azure and AWS in terms of market size. And finally, Loop is growing as a team as well. So if you're looking for cloud engineers, DevOps engineers, software engineers, backend and mobile, I mean, we are hiring. Feel free to reach out to me on LinkedIn, Ali Salhi at Loop on LinkedIn, and hopefully we can have a conversation.
Awesome. Yeah, guys. So if you're looking for one of those positions that you mentioned, please reach out to Ali. I mean, y'all are on some rocket ship pace right now. It seems like, from a growth perspective.
Yeah, we're at a phase where we're actually intentionally trying to control growth so that we can kind of like focus on things that we want to focus on, because growth for the sake of growth is not really helpful for longevity. So we're actually at a place where we have the freedom or the luxury to control our growth, kind of like put the gas pedal, put the brake pedal a little bit, try things out so that we're very sure when we want to just do breakneck growth, hopefully over the next year.
So I know you mentioned you just finished, I don't know how long ago that was, that y'all finished raising your Series A. Are y'all in the process of starting to raise for a Series B now?
No, we're well capitalized at the moment. We're well capitalized to go and hit the targets that we've set for ourselves. So we're definitely not looking for a Series B right now, but we will be at some point in the future.
Yep, absolutely. So we have a few more minutes, and if anyone has any questions for Ali before we let him go, and then we'll be taking a 20-minute break, and then coming back for the second half of our day. So if you have any questions for Ali, please put them in the chat. We'll stick around a little bit, And if you have a couple minutes, Ali, see if there's any questions that are going to be coming in here for you to answer. But I'll definitely be connecting with you offline. Where are you located?
Austin, Texas.
Okay.
Yep.
Startup hub of Texas. So
yeah, it's starting to become the startup hub of the US apparently. So
yeah, y'all in Miami are neck
yeah,
and neck.
yeah,
So
Austin and Miami.
is Loop based out of Austin?
Yes, Loop is
Okay.
based out of Austin. I believe like Miami is very very heavy on Web3 and kind of
Yes.
like that spectrum. And I feel like modernizing industries is more about like is more what Austin is about. So there's a different type of talent, a different type of focus for both cities, but they're both really just winning talent and people from the West Coast and the East Coast.
Yeah, no, I have a lot of friends, and I'm involved with a lot of organizations that are based out of Austin as well. Founder Institute and Capital Factory. I'm not sure if you're familiar with them, but yeah, I've just seen the exponential growth, not only from like talent and like startups, but just like the city as well. It's such an awesome city. It's quite interesting. I was trying to get an Airbnb a couple of weeks ago in Austin. It was nearly impossible.
Yeah, no, it's everybody seems to be coming to the city. Well, I mean, including myself. I moved here 4 months ago. So
Where'd you come from?
New York.
Okay.
Yeah, the traditional. Either you're coming from New York or you're coming from California.
Yep.
Yeah.
Cool. Well, it doesn't look like we have any questions. I really appreciate your time and the presentation. That was awesome. Thank you so much again. I hope you stay safe and healthy, and we'll look forward to connecting with you.
Yep. Thank you very much. Thank you for having me.
Absolutely. Have a great one.
Bye bye.